So this is my font that I designed to be more easily 3D printed on the first layer of a 3D print. So essentially, right? Oh God. Oh God. So, what this font does is it is a group of letters, right? Because that's what a font is. That whoops. What this font is it is designed to be more easy to be 3D printed on the first layer than any other font I've ever used, right? The purpose of this font is if I have a thing that needs oh my God. So the purpose of this font, right, is that if I have something that I need to 3D print that needs text on it, and it needs to be printed flat, and the text has to be flat on the bottom surface, right? This font is designed to make that easier. It's not going to be perfect, because nothing's ever perfect, but it'll increase the chances of having a successful print if there has to be text on the bottom, right? So I'm going to extrude this. It's probably going to also going to want to do that thing, right? There are a lot of polygons here to calculate because this is a very long sentence, because this is more words than anyone's ever going to need, you know? But anyways, when for some reason you need to have text on the bottom layer of a 3D print, right? Or when I need to have text on the bottom layer of a 3D print, I'm going to use this font, right? Because I designed this font to be 3D printed on the bottom layer more easily than other fonts. So as a point of comparison, right? I'll put a new sketch here. And then I'll put a similarly shaped object here. And instead of using this font, I'll use I like to use Arial Black sometimes. Or Arial, right? 5mm. I'm going to type not this whole thing, because goodness, that takes forever. But I'll type the quick brown fox jumps over the lazy dog, and again in lowercase. Right? You will notice that it is a bit bigger. You will notice that it is a bit bigger, and that is by design. So if I show this off, right, these letters, for one, left a bunch of holes in there, right? Look at this. There are a bunch of bodies now. If I was to suppress this, now look at how many bodies there are. Now look at how many bodies there are. There are 3. That's because the font was designed, right, not to leave any of those erroneous bodies when it's cut out of something. Another feature it has, designed to make text easier to print on the first layer, is the lowercase letters are the same size as the uppercase letters. You will notice on the normal font, right, that this T is a little taller than this T. The O is much taller than this O, right? And that, I believe, allows this to be smaller. But anyways. Oh, you know what? I just realized this isn't actually smaller. It's just less words. Anyways. Another thing that's unique about this font is the letters themselves. The thing in the computer that is the letter, right, is not the letter. The letter is the negative space of this font. Because when you cut it out and leave the letter, I think that's easier. It also looks, I like how it looks better. Something that you'll notice is that there are still these itty bitty little spaces, little thin sticks inside here in the font, right? In between the letters. Until you get to a size of about 20 millimeter letters, these things won't show up in the slicer, right? If you go up to about 21 millimeters, right, and you turn on print thin walls in the slicer settings, then these will show up. If it's turned off, though, if print thin walls is turned off, these won't show up until about 285 millimeters, which is about as big as most. It's so big that most 3D printers can't fit more than 2 letters on them at that size, which means that essentially these are never going to show up, right? So to demonstrate that, I will go ahead and take this body and save it. Where am I putting this? I'm going to put it in... Here. I'm going to name it Verbose Fox. And now I'm going to open up Cura, which is a slicer that most people, or not most people, that many people use. It's a little bit less popular these days, I think, according to like just what I've seen, right? People seem to be using Prusa slicer nowadays. I started with Cura. I know how to use Cura. I don't feel like going through the effort of learning Prusa slicer or anything else. I think another one that people seem to like is Orca slicer. And of course the Bamboo Labs things are pretty popular. Anyways, Cura. I open... I will search for this. Verbose Fox. I will center this. And if you look at the preview, this is going to take 2 hours because it's very big, but you will see a lot of travels, but there isn't a single one of these little walls being printed here. Now this is print thin walls is turned on, which is insane. If you turn it off, obviously yeah. Now I've got it. I designed this to be printed at a minimum size of 5mm tall characters. That's because with other fonts, I've only ever been able to get 5mm tall characters. So that's what that's about. I believe if you're lucky and very good with build plate adhesion and bed leveling, you can probably get this down to 1mm, because when you change the size of the font to 1mm, this is going to take a long time to calculate. Hang on. In hindsight, I probably should have just made a new sentence to show off what 1mm looks like. But anyways, I don't ever intend to use this at 1mm. 75%. Compute finished. Nice. Okay, so at 1mm, if I create a new sketch on this face, (14,000 square millimeters). I never noticed this calculation be here before. Because when it starts to sketch, it usually happens so fast. It usually flashes in and out so fast that like I never notice. It's just a thing there that flashes in and out. That's funny. This might crash. Yeah, there are far too many characters here. It would have trouble if I had that many characters with normal font also. But I feel like I could probably get away with... Yeah? I feel like I could probably get away with slightly more characters with another font, with you know, the program not spitting at me about too many polygons. Yeah, in hindsight, I should have just made a new sketch because this program has decided to stop responding. Oh, what is this? What is this? Something's happening. Something's happening. The loading bar is moving. Oh. This says, the quick brown fox jumps over the lazy dog, who himself is also rather quick, but was ... reason as if the dog had not been so lazy, he could have easily outjumped the fox ... Fox, who is less quick but also less lazy. There we go. Okay. Now the reason I think you could get away with 1 millimeter if you're being lucky is if you measure... Oh God. It's going to not want... If you measure the distance between this and this, you get 0.2. Okay, never mind. You can probably get away with 2 then. Because with 2 millimeters, it's about 0.4. I forgot that. I thought it was 1 millimeter. I don't think I'm gonna go ahead and finish the sketch here. I'm going to hide all of these bodies. Okay. And now I'm going to make a new one just to show off 0.2 because I want to show off 0.2 or 2. Hello. I called it 3DP inverted. Bring back the sketch. Okay. Now, if I put a sketch here and I measure this, that's 0.484, which is pretty close to 0.4. So, if you're very, very lucky, a 0.4 millimeter nozzle can extrude this, extrude this, extrude this, extrude this, infill this, extrude this, and extrude this. But I designed it to be printed at 5 millimeter text height. Because if the text itself is 1 millimeter or 2 millimeters tall, it's honestly too small to read anyways. Now, in most cases, I'm actually going to be using a bigger size than 5 millimeters. And to demonstrate that, I'm actually going to show off right here that in this recent project that I did, I actually did use this font. And this font is set at 6.5 millimeters tall. And it looks quite nice and very good at this size. Very easy to read. And in the project, it works flawlessly. Don't save because there didn't make any changes. So, I believe that is everything that needed to be explained about this font. I did need it is pretty interesting because I did need to make some interesting decisions about the design of certain characters in order to get them to reliably succeed on a first layer. For example, the E, the capital E, you'll notice the middle line of the E is not a line but actually a curve. Obviously, because I don't want this to cut the letters out, because cutting the letters out creates an ungodly number of erroneous bodies. All of the letters actually go all the way up and all the way down. And if you imagine the curve of the S continuing, right, it would go into into the rest of the piece here, right? They essentially intersect, or the letters are kind of look like they intersect with the rest of the body. What else have I done? What else have I done that's strange? Oh, hang on. Okay, the lowercase k is weird looking, but it still reads as a K. This shape is because with a regular lowercase k, this top part here is a stick shape, and that would peel up and not stick to the build plate as easily as this shape does, and it would be harder to print and harder to succeed. So this is gone. I removed that bottom gap there in the lowercase k because it never showed up in my testing. There are no holes, right? There are no holes below a certain size in any of these letters. That's inside the letters, right? For example, this here is technically a hole, but it's not inside the letter. It's kind of just because the letter is touching the border, right? Just like this one here. There's no holes inside the letters except for the O and the uppercase Q, and that's because the O didn't look very much like an O without the hole, and the O in the hole was big enough to reliably succeed, to successfully come out. Same with the uppercase Q, because the uppercase Q is the same shape as the O but with a tail. So there are some strange, interesting shapes here, right? Like the lowercase t has the same thing as the uppercase E with the curve rather than a stick. There's a lot of that actually in here. But then there are some other ones that are kind of just normal, like the X is just a normal X. Anything that like has a corner on the outside of the letter, right, is rounded. This is because a sharp edge can peel off more easily than a rounded edge. The inside corners I would have liked to round, but they ended up not looking very much like any letters at all when I did that, which is why I stopped. Which is why I didn't do it. But that's not quite so important as rounding off these outside edges. So essentially, right, I designed all of these letters to be easily 3D printed on the first layer, right? And this is not to make it easier to put a letter on I'm not making it easier to put a letter on the first layer of a 3D print so that it could be done all willy-nilly. It's just if I have no other option, like in that project I showed off, that was the only option for what I was doing, right? So if I have no other option, I will turn to this font, and this font will more reliably succeed than anything else. And so that is my 3D printable font, or rather my first layer 3D printable font. I called it 3DP inverted. It had to be named 3 spelled out THREE DP inverted because for some reason computers don't like it when you have a number in the name of a font. I don't understand why. But yeah, that is what I have to show here is basically just all these letters. And I do have the numbers as well. If I make another sketch here. Oh, I can't. Oh, no. Oh, no. Oh, no, I clicked on the face. I showed off actually, the letters were actually visible in in that project I showed off. So I have the numbers. I have the numbers as well. So that is that. This was actually pretty tough because because most text is not designed to be manufactured, and if it ever is designed to be manufactured, it's not designed to be manufactured via 3D printing. It's designed to be manufactured by some other technique. So I honestly believe that this is a unique and novel thing that I have done. Maybe not so novel, but at least very unique, right? The shape of these letters was entirely informed by the process of 3D printing, which is kind of funny because the shape of letters, which is not as okay, so that sounds right, like I'm giving up a lot to the process of 3D printing because I need the letters to conform to certain rules for that, right? But most alphabets are shaped the way they are shaped due to the initial process that they were invented for, right? The initial writing process that they were invented for. Like there's an alphabet that exists that is written by scratching on leaves, and that makes it very hard to make straight lines, right? And so the letters in that alphabet are all very curvy, right? The Greek letters? No, Roman, right? The Roman letters, these letters, right, are designed to be... Well, I can put text here now. So these letters, right, are designed for the process of being 3D printed, right? Ooh boy. But the original design of these letters, right, was designed to be scratched into stone, I believe, or wax, right? And so that gives them a different shape. The 0 also has a hole in it for the same reason as the O. It doesn't look like a 0 without it. The 6, the 9, and the 8 get away with not having holes in them, as does the B. Where's the B? As do most of the other all of the other letters, right? It's only 0, capital Q, and O that have holes in them. Other than that, there are no holes in the actual letters, right? C, capital A, no hole. D, no hole. Where's another one? P, no hole. Another interesting challenge was the lowercase I and J. The dots, right, which normally are floating in most fonts, which is fine in most fonts, cannot be floating when they are designed to be built out of a physical object, right? So I connected them with these tiny little lines that don't show up until about 10 millimeters, I believe. These lines won't show up until about then, but by then they're so small compared to the rest of the letter, right, that it's not that it doesn't look not like an I or a J. See, even at this size, it looks very much like a lowercase I. So, yeah, that is my font that I've designed to be 3D printed. It's kind of funny because, like, honestly, the way it started was I knew I was going to have to do that project that I just showed off. I applied this in that project, and I knew I was going to have to do that. And I thought, I don't like any of the fonts that I have because they're not designed to be 3D printed like that. So I thought, but I also thought I don't want to have to design the lettering every single time I put letters in something. So I just designed the letters once, and now I don't have to do it ever again. You know, that's honestly the point here. So yeah, and then is there anything else? No, that's it. So yeah, this is my font that I designed to be 3D printed. It works pretty well. It's got a better success rate than other fonts, even other stencil fonts. Right, I have other stencil fonts on here that I used before I designed this one. Those would have a success rate of like, I don't know, 50%, and then when they did succeed, they never looked very good. This has a success rate closer to around 75-80%, and when it succeeds, it always looks good. So it's far superior. Well, in my mind, it's far superior to anything else I have on my computer. So improvements that could be made to this font, I don't know. I'm not good at making fonts because I've only ever made this one. If I could figure out how to get rid of these itty bitty tiny little wisps here, I would. But as far as I can tell, there needs to be at least a teeny tiny amount of space in between the letters in order for Fusion to not have a panic attack about, is it, hang on, is that ableist to say panic attack about a computer? In order for Fusion to not complain about when you want to extrude it. It just, I don't know why, but if the letters are touching, it doesn't like that. And that applies to every font in here. It's not just this font that I created. If I put a sketch on, not on one of these pieces, but here, right? If I use, where was that? It was, there was a font here that was cursive. No, not that one. Was it this one? No. Also, that one doesn't seem to have... I'll know it by the X. I have other fonts in here that I have downloaded. I've downloaded like about 8 fonts that I thought would be easy enough to 3D print. None of them have worked, and that's why I resorted to just designing my own. I don't think... Okay, is it this? Is it French? No, it's the one underneath it, I believe. Yes, it's this one. Okay. These touch, right? So if you extrude them, Fusion is going to tell you, no, I can't do that. See, fail to perform Boolean operation. But if I go back in here and make it so that they don't touch, you can do that by changing the character spacing, by the way. I learned that through this project. Uh, 10? Yeah, now they're not touching. And then you can go ahead and extrude this. And Fusion will not tell you that it's horrible and wrong and gross and ugly and disgusting because there's space between them. And I believe the reason why Fusion doesn't like for the font for the letters to touch is because if they're touching, then it doesn't know what to do about like this line here, right? These 2 lines. It doesn't know what to do about them. So yeah. Anyways, Also, this is basically the reverse of what this font is designed for. So improvements to this font could probably be, again, if I was going to find a way to get rid of this, I would. I might look into changing some of the shapes of these to be a little bit easier to read, but most of these are just fine. I might design. Okay, I might do one that is just these characters again, but the inverse of this, right? So instead of the character being the space around the character is the character, right? And the reason for that is mostly so that I can the reason for that is so I can do this, watch. If I extrude this, right? See, these are sticking out, right? But if I were to change that to my 3DP inverted stencil font, so it would be in the T's, put that in there so that it actually, right? Now it just looks weird. So I might in the future want to make a non-inverted version of this, right? And another advantage that has is that these little walls won't show up. And then a third advantage that yet another advantage that has is I can kern these better, right? I can make the spacing look better. So for example, the R and the O are a little bit awkwardly spaced. They're a little far apart looking. But I can't make them any closer because this is the letter, right? This space here is the letter. And if they were closer, right, they'd be intersecting. If I made this closer to this, then the letters would be intersecting and Fusion would throw a fit about that. So that's another advantage to making an uninverted version of this font is I could kern more appropriately. I don't really know if I feel like going through that though, because the program I used to make the font is kind of annoying compared to Fusion. And from what I can tell, people don't ever design fonts in font makers. They use font makers to trace the letters. Like what I did was I designed these in Fusion, and then I took screenshots, and then I traced the letters. Because there has an auto trace button because it knows that people just are gonna trace it, you know. So yeah, improvements I could make are I could make a non-inverted version of this for the purposes of building characters out instead of cutting characters, right? And then if I can figure it out, I would love to get rid of this space here. And then one last thing is I might also design a font that is designed to be easily printed on the side of an object. That I don't think that's quite so necessary, because if you put characters on the side of an object in most fonts, it usually comes out just fine. So if I put it in Arial Black, or just Arial, which is, I'll do Arial Black, and I put Ho High instead of Hi Ho, and then I cut this in, right, by 1 millimeter. This will get 3D printed just fine. Even that little overhang in the O, right, that's sticking out. It's only 1 millimeter deep, and so it's not going to actually fail at all. And the slicer might put a little bit of support there, but if I was going to, right, I would design this to be printed sideways, right? If I was going to design this to be printed sideways, right, I would like make the dot in the eye. I would give this like a rounded shape, or at least a chamfer there, and I would give that a chamfer there, right? I'd make that a little. I don't know what I do about the H, but if I felt like it, I would design it to be so easy to 3D print, right? When cut through the side, that like you could make a letter that is like the size of this face here, and it would print without supports, right? But that's not even this font then, right? That's a different font because it would have a different purpose in mind. This one is for being the first layer of the print. That other hypothetical font that I'm talking about would be inside the edge of the print. So yeah, I honestly can't think of any improvements I can make to this other than maybe slightly better optimization of the shapes. The N could be a little thicker here, right? It could be a little wider. The W could also maybe be a little bit wider. They're fine. They're fine for now. This reached a satisfying point to conclude. It reached a point where I'm happy using these letters in just about anything I'm going to need them in. So this is my 3DP inverted stencil font. And I'm honestly really happy with it.